Alright, so when you're looking at matrices, don't forget you have different things you need to look for. First thing is the order of the matrix. Now, can someone tell me the first one? What do you always look for first when you're looking at order? So rows and columns, right? Now, if we're looking at rows and columns, how many rows are there here?
2.
There's 1, there's 2, so that's 2. How many columns? 3, so that's 2 by 3. Yeah, remember it's rows by columns. I should actually change it to a times.
No, 3 by 1.
3 by 1, that sounds very good. And then the next one? 2 by 2. Good, this looks good so far. Okay, so one of the key things that you have to make sure when you're adding matrices is you have to make sure that they're the same order. What that means is you have to make sure the matrices are the same size. Now, remember that's different to multiplication. We'll go through that in 1 second because that's the next slide. But remember, when you're doing it for adding and subtracting, make sure it's the same size. Okay? I would suggest you write that down in your book because you will be tested on that, on whether or not it's the same size. Alright, is the first one and the second one the same size? Yeah. Yep. If it is, then you can actually subtract it. Remember, when you're subtracting it, you're only doing it element by element. So if it's on the top left, we have a 1 there, and that's on the top left there. We're doing 1 minus minus 1, because there's a minus there. If you're doing it on the top right-hand side, we have a 4 minus 0. On the bottom left, you have a minus 2 minus 4. And then on the bottom right, you have a 5 minus 7. So from here on, hopefully you get the point by now if you've done your practice. You just add and subtract them. So you get 2, 4 minus 6 minus 2. Okay. On here, you'll notice that they're not the same size. Because you can't add them, what you need to write down is you need to write down that they do, does not exist. So make sure you always double check whether or not you can add them or subtract them by checking if they're the same size. Any questions? Yep, all straightforward. Okay, now multiplying matrices. All of this is a long-winded way of saying whether or not they work. If you want to read it, feel free to read it. I'm just going to simplify it down by showing you an example here. What's the order of this matrix? 2 by 2, sounds very good. And this one? 2 by 1. Good. First line. The first line says, check that these two numbers are the same. If they're the same, we're good. Okay. Second line. Second line just says that when you multiply this out, I'm going to put it on the right-hand side, you should get a 2 by 1 matrix. All right. Now that we know that we can actually multiply it, does anyone remember how you multiply it? Yep, so it's always rows by columns. Row by column. That'll be your first one. We're looking at the first row and then first column, and this will pop up on the first row and first column of that one. So we have minus 2 times 1 plus 0 times 0. So we've done the first row and first column of the first one. What's left? So we're doing the second row and first column now, plus 4 times 0. Once we add it together, we have negative 2 there, and that'll be 1 plus 0, so that's a 1. If you have a look at the top here, you should actually be able to see that this is actually 2 by 1. If you count the number of rows, you have 2 rows, and you have 1 column. That matches up nicely, doesn't it? Okay, second one. Can we do it? How many rows? On the first one, 3 by 1. Second one, 2 by... Okay, the middle two numbers aren't the same, so this one does not exist. Any questions on that? Okay, most of the time you'll be multiplying with square matrices, so I'm just going to do one on here. I made it so that this kind of looks like the identity matrix, but it's not. What you should notice is it will actually swap the rows. No, we'll swap the columns around, I think. First one you always do, first row and first column. Negative 3 times 0 plus 4 times 1. And we're doing the second column on the right here. So we're doing negative 3 times 1 plus 4 times 0. Then we're doing the second row. We have 6 times 0 plus 0 times 1. And then on the next one we have 6 times 1 plus 0 times 0. What do you get on the top left? What do you get on the right? Have you guys noticed that the column swapped? So finding inverses. One of the key things that I've been noticing a lot of people doing, when you're doing the determinant, make sure you read that section there. The number of the bottom part of that matrix is called the determinant. So that means it's only for the number on the bottom. So the determinant is literally only AD minus BC. If you write it out as 1 on that number, I will mark it wrong. Okay? So make sure it's just that times that, and then subtracting that times that. Okay? So if you need to, it's written right here. Alright, so let's just double check our understanding. A inverse, the top left times the top right. So negative 1 times 6. And then we subtract those two multiplied together. Negative 4 times 5. And then we swap the two here. So 6, negative 1. And then we take the negative of those two. So negative 4 becomes 4. 5 becomes negative 5. Once we add that together, we get, that's 20. Remember, that's a plus 20. 20 minus 6 should give us a 14. And you just write the matrix out. You are allowed to leave the matrix in that form. When you're multiplying different things, you can actually just leave this fraction part out. Okay? You don't actually need to write that into the matrix. You can if you like. It's not necessary. Okay, applications. My biggest suggestion to you would be think about it like algebra. Matrices are pretty much numbers, so it works the same way as algebra when you're solving for stuff. So if you think about this, this is kind of like 3m minus 2 equals to 5, right? You would actually put the 2 on the right hand side, and then you just divide it by 3. This is exactly the same. You put that onto the right hand side, okay? Once you've added it up, you just divide it by 3. Now because we're dividing it by 3, when you're dividing it by 3, make sure that you just leave the 3 outside, unless you want to multiply it in, or if you're told to multiply it in. Otherwise you can actually just leave it outside. For this one, obviously you can divide each one by 3. It's pretty easy to do so. I'm happy for you to leave it as it is, if I'm telling you to solve it. Feel free to leave the 1/3 in front. You don't actually have to solve it. Two more things. AX minus B. AX equals to B. The A's on the left, you multiply this on the left. If A's on the right, then you multiply A inverse on the right. All you need to do first is find A inverse. Once you've found A inverse, then you just simply multiply it in. So the first one, I'm not going to show you the full set of working out. That's for that one. If it's for this other one, then we need to do B first and then put in A. If you have two equations, make sure you firstly set them out vertically. Once you've set them out vertically, then separate it into 3 matrices. So these are just the coefficients of x and y. There's your x, there's your y, and put down the numbers on the right. And then your last step is to put it into matrix form. Now remember, this bit's on the left, so we need to solve it on the left. So 2, negative 3, 1, 2 to the power of negative 1, and then times the other matrix. If you're up to this step, if you're told that you're allowed to use the calculator and you don't have to show you working out, I'm just going to quickly show you how to put it on the calculator. So when you're putting it on the calculator, remember you can load up the keyboard, put the matrix in, and I have to actually manually click the numbers, which is unfortunate. Now remember we had an inverse, so you can actually put into the power of negative 1. Please remember that it's a power, and then you multiply it by the other matrix. Ta-da! There's your answer.